When naming chemical compounds, the best place to look is the periodic table. You start off, if you take a look at the first element in the compound, that will pretty much tell you where to name it and how to name it. And so, for example, if I have this X2Y, in X2Y, I look in the location of the X. If the X is is hydrogen, then I know that my compound is an acid. So if I take a look at my compound, then I know right away that if the first element is an H, then I know it's an acid, and I name the compound using the rules for acids, which you'll actually find on that handy helper page. So if we look over here, we can see that HCl starts with an H, so that's an acid. So if I look on the rules, we find it's binary, and we name it as hydrochloric acid. Now if I take a look, if that first element in the compound is in what I call the just name it section, the just name it section is pretty much groups 1 and 2. So groups 1 and 2 are the alkali metals and the alkaline earth metals, and those transition elements that did not have different oxidation states, so aluminum, zinc, silver, and cadmium, then I pretty much can just name the compound. Well, what do I mean by just name it? You just say the name of the cation, you just name the element, the first element, X, and you change that second element to IDE. That's a common practice, usually for most compounds. They're going to end in IDE unless they contain a polyatomic ion or they're an acid. So if you're looking at your compounds and you've written things like sodium chlorine, you know you've messed up because the ending was never going to be the same as the periodic table name for the second element. So I take a look at Na. Na is sitting in the just name it section. Yay! So I just name it sodium, change the ending to Cl to IDE, so sodium chloride. Now this middle section is a little harder to deal with. The middle section that has multiple oxidation states require a Roman numeral. That Roman numeral represents that oxidation state. It's not how many elements are in the compound. A big mistake people make all the time is they give me the Roman numeral as how many elements. This is not copper Roman numeral 1 chloride. It is actually copper Roman numeral 2. Well, how do I know that? Well, I know that chlorine is a -1 charge because chlorine right here is in group 17, remember, and you should have written on top of your periodic table a little -1. And so I know that 2 chlorines would be a total of a -2. Well, this whole compound is neutral. It has no charge, so it needs to balance out. So what will balance it is a +2. Well, 1 copper gets all that +2. So this is going to be copper Roman numeral 2 chloride, and that's what you would write down. You would literally write down the word copper, and then you would write a Roman numeral 2, and then you would write chloride. Sometimes you'll see that Roman numeral 2 in parentheses. So we can put those in parentheses if you like. So copper Roman numeral 2 chloride. The last section that we deal with is if that first element, X, is sitting over here past the stair step. Notice past the stair step starts with a P. So if you go past the stair step, you need a prefix. These are your covalent compounds. And so anything that starts with a metal, the sodium, the copper, anything in the purple section, the just name it or the Roman numeral, those are ionic compounds. Acids are actually covalent compounds with ionic character. And then you have your covalent compounds. They all start with one of these guys. And so if we take a look, if your element starts, your compound starts with one of these guys, then you require a prefix. I meant to make that black, but it didn't want to go that way. Okay. So there you go. So if it starts with one of these elements, then I know that it's covalent and it requires a prefix in it. Well, your prefixes are on the list, and it's just telling you the number. So if I look at CO2, how many carbons do I have? I have 1 carbon. Prefix for 1 is mono. We just never start a covalent compound's name with mono. We use a mono if it's on previous, or it's on the second element, but not on the first. So this would just be carbon. The prefix for 2 is di. We change the ending to IDE, so carbon dioxide. You know that. You know the name of CO2. We breathe it out. So how would we name this one? So we take a look. Where is N? Is N in the just name it? No. Is it in the Roman numeral? No. Sitting over here in the prefix section. So we do to dinitrogen, just like we did carbon. We don't change the ending of the first element. We just give it a prefix if it requires one. It's not a mono. But we do change the ending to S, so it's trisulfide. So then if we take a look, this little handy helper sheet kind of tells us the same thing. Does it start with an H? If it does, yes, then it's an acid. Here are the rules. And we'll go over those a little bit more in detail later. If it doesn't start with an H, then you need to ask yourself, is it binary? Binary means it contains just two elements. If it is, it's going to end in that IDE that we were talking about. That second element will end in IDE. So if it contains a metal, then you have two options. Type 1 metal, just name it section, or type 2 metal, Roman numeral section. So this kind of corresponds with the periodic table we were just talking about. And then if it's not a metal, it's a non-metal, it's past the blue line, then it requires a prefix. And here's your list of your prefixes. Yes, you need to memorize these. You know them pretty well. People kind of mess up on 4, tetra. Think of the game Tetris. Octa, think of an octopus. It's got 8 legs. And so you just need to memorize these prefixes, and you need to know when to use them. Don't go prefix happy on me. You're not going to use prefixes if your first element, X, is a metal. You only use it if you're all nonmetals, covalently bonded compounds.